This is going to help you with looking at station models and just general surface maps and get some idea of what they actually look like, what's on them, and that kind of thing. I want to start with the station models. Week 2, the chapter 2 and the AMS really works good with showing you how to step-by-step look at these. I'm in a website that's called real-time weather data. It's the rap.ucard.edu website. Really great. It's in Blackboard underneath the weather websites. There's a link for it to go straight to it. And if you look at their help pages, is when you come to this website, if you hit the home button, you can go to help pages. You want to look at the surface data, and it gives you a really good way also to looking at station models. Your book has it, the manual has it, and then you, of course, there's lots of places across the internet, but this is a really good one on the internet as well. You look at the station model, it has a little circle. If there's nothing going on cloud-wise, sometimes on some websites you'll see it as listed as a square, like a green square. This one shows that the middle of the circle is covered partially. If it's covered partially, then it's got some kind of cloud cover. If it's like this one, 3/4 of the sky is covered. If it was completely blackened in or colored in, whatever case of what website you're looking at, you look down here at the bottom, then it would be considered overcast. You got broken, which is the 3/4. You've got scattered, where you just see like 1/4 of the sky. You've got a few. It would look like that with kind of a line through it. Would just tell you that there's very few clouds. Of course, completely clear. This website uses a square. Others may just keep it as a circle that's completely open. So that's what the middle portion is. The top part, the number up to the left, the upper left, will be the temperature. It's done in Fahrenheit. All surface data in the United States is done in traditional units. Everything else, like the upper air data, is going to be in more standardized units that are used everywhere, and that would be like Celsius. Okay, looking at this, the temperature is the top number, the bottom number is what they call the dew point. It's where the temperature has to get down to in order for saturation to occur. So in this case, the temperature would have to drop to 61 for saturation to take place at the surface. In between the two, if there's weather going on, they'll have some type of symbol. Now, there's a whole listing of symbols on this website where it tells you, what the symbol actually means. So that's a thunderstorm. So in this case, DEN for Denver is having a thunderstorm. And it could have been rain, it could have been snow, could have been anything in there, any one of these symbols that are listed down here. Now, if there's a number or a fraction, it could be either one, off to the left of where the symbol would be, that would tell you that there's visibility issues. If the visibility is greater than 10 miles, you're not going to see it listed. And a lot of times if it's greater than 5, they probably won't list it at all. They won't have a number there. If there's no number, the visibility is good. If there's a number or a fraction, then the visibility is poor. And so therefore it's listed. On the other side, when you're looking off to the right, is the pressure. It's a 3-digit number, and what you do is you have to decode that number because it's always listed as a 3-digit number. So we're going to figure out what the pressure is in millibars. There's a point right here. So what you do is you take that decimal point and you move it one place to the left. So now you're going to get 0.5. Now we have to decide, do we add a 9 or do we just add a 10 in front of that? If we were to add a 9, it would be 900.5. If we were to add a 10, it would be 1000.5. And as a general rule, you want to keep the pressure somewhere between 950 and 1050. So 900.5 obviously does not fit between that range, so it has to be 1000.5. Last thing is the wind direction and the wind speed. So you're going to have a line coming off of somewhere along the circle, or if it's a square, there's going to be a line coming off of it, and that's going to tell you the wind direction. Remember, wind is measured from the direction it's coming from. Think of this as a compass, so you got north straight up and down, east, south, and west. Now if you have, like in this case, the line is coming right there, then straight down is south, over here is east, so you would say it's a south-southeast wind. If the line was coming straight up, it would be a north wind. If the line was coming right here, straight across, it would be an east wind. That's how you're going to look at it. Remember, it's always defined by the direction it's coming from. So if it's coming out of that east portion, it is an east wind. The wind speed is listed as a line. So if the line is coming off at the very end, it tells you that it's 10 knots. A knot and a mile per hour are pretty similar. One knot equals 1.15 miles per hour. So it's very similar. So when you're talking about smaller speeds, they're more or less the same. And you can kind of think in your mind as them being the same. When you're talking about larger numbers, obviously that difference will be a lot bigger. But when you're thinking about surface winds, typically they're going to be 10, 15, 20, 25 miles an hour, that kind of thing. And you can, in your mind, kind of think of, if it's 10 knots, it's roughly 10 miles per hour. I mean, it's obviously not exact, but when you're just kind of looking at it, instead of having to sit there and constantly figure it up, you can, in your mind, visualize that. So if it comes right off the end, it's 10 knots. If it comes it's like a half one, then it's going to be worth 5 knots. And if it's a 5-knot wind and nothing else, it's just 5 knots, they don't stick it on the end because that gets confusing, so they'll push it back a little bit, and then you'll see like a little line coming out, but you'll see the rest of the stick on there still jetting outwards. So just kind of a little FYI. So you got each one of these lines would be 10, so if you have more than one, say you've got 2 lines, it'd be 20 knots. You have 2 full lines and a half line, 25 knots. That kind of thing. A flag would be 50 knots, which you're not really going to see at the surface unless there's something really crazy going on. But typically that's something you're going to see in the upper air chart. Alright, let's do some practicing. This website, you can go to their surface data page and get the same stuff. I'm going to flip to the AMS, the one that you use for everything else, because it's in your manual, it's a lot more familiar, even though they're the same, but everybody's website has things just slightly different of how it looks, and I try to stick with stuff that you're more familiar with. We're going to look at a couple different stations. Now, the first one, we're going to look in Arkansas. And the reason I'm picking this one is you can see the temperature, 81, dew point, 47. The pressure is going to be 1019.3. The difference on this one is you see it has cloud cover, so it's showing you that there's broken clouds, that 3/4 of the sky is covered, but there's no actual wind information. If you ever see a circle and then another circle around it, then that tells you the winds are calm. They're less than 5 knots, so they're not listed as anything. Even listed as it's, north wind, south wind, it's just calm. So that's what that is all about. Let's look at one that actually has a wind barb on it. Let's look at the station in West Texas right here. Temperature is 84, dew point is 58. There's a circle and it's completely open, so it's clear skies. The pressure is 1013.8 millibars, and the wind is pretty much out of the south, due south, and it looks like it's 15 knots. So there's a long line and there's a short line. So that's how you read those. Now also in the Chapter 2 information, you're looking at basic features, which you've kind of already done several times through the last couple weeks. Let's go over it one more time. All the L's are lows, all the H's are high pressures. The fronts, cold front, has got triangles. On one side it shows the direction of movement. They're blue if it's a colored map. You got warm fronts, which are red semicircles. And again, that shows a direction of movement as well. If you've got alternating triangles and half circles, then it's a stationary front, meaning it's not moving. This map happens to show you any radar that's going on, so any precipitation that may be falling at that time. Remember the date and the time listed in Z time, which is the UTC, the date that it actually occurred. Remember, fronts may not necessarily be at the exact same time, so they don't analyze it every single time they generate a new map. So the fronts were done at 15Z, and this actual map with the data, meaning the surface observations, was 17Z surface observations.